Our journey now leads us to the grandeur of our native galaxy, the Milky Way, spanning approximately 100,000 light-years in diameter. This vast spiral galaxy harbors hundreds of billions of stars, each potentially with its own planetary systems. Within this magnificent structure lies a small sphere known as the human radio bubble, extending about 100 light-years from Earth. This bubble represents the furthest reach of human influence in the cosmos, with our radio and television transmissions beyond this bubble, as if humanity had never existed. Any civilization beyond the vast majority of our galaxy would be unaware of our presence, as our signals have not reached them. The scale of the Milky Way is so vast that all our recorded history is but a whisper in the undetectable cosmic wind. As we leave behind this small bubble, we venture beyond the Milky Way, entering the vast and almost incomprehensible realm of intergalactic space. Galaxies float in the cosmic ocean, separated by unfathomable distances. Our galaxy is part of a small cosmic neighborhood known as the local group, a collection of over 50 galaxies scattered across approximately 10 million light-years. This diverse grouping is home not only to spiral galaxies like the Milky Way and Andromeda, but also to a multitude of smaller dwarf galaxies. The distances here are so vast that light would take an incredible 10 million years to travel from one end to the other of the local group, transcending any scale within our own galaxy, highlighting the grandeur of the universe. Intergalactic space is a silent expanse, a vast desert between the islands of galactic light. Our galaxy, which houses all our history, is just a small blotch among the many narratives in the great cosmic library. As we expand our cosmic view beyond the local group, we encounter the colossal Virgo supercluster, an immense collection of galaxy groups and clusters, including our own local group, spanning a region of space about 110 million light-years in diameter, or 33 megaparsecs. The Virgo supercluster is a titanic structure in the universe, containing thousands of galaxies, and at least 100 groups and clusters of galaxies, each with its own profusion of stars and planets. As we leave the Virgo supercluster behind, we enter an even more impressive cosmic structure, the Laniakea supercluster. This immense congregation of galaxies, which includes the Virgo supercluster, extends over 500 million light-years, truly being our galactic home on a grand scale. Laniakea, whose meaning in Hawaiian is immense sky, truly lives up to its name, housing the mass of 100 million billion suns. This gravitational masterpiece is a spectacle of superclusters of galaxies and countless celestial bodies, all interconnected by a cosmic web of attraction and movement, pulsating at the heart of Laniakea. At the heart of the Laniakea supercluster lies the Great Attractor, an enigmatic region of the cosmos that seems to exert a tremendous gravitational force, drawing galaxies towards it with invisible authority. Within this vast expanse, where our Milky Way is just one among hundreds of billions, the local group and even the Virgo supercluster are tiny cogs in this colossal structure. Laniakea offers a profound perspective to our existence and shows us that we are part of a significantly vaster and more majestic cosmic tapestry than human understanding can fully grasp. When we touch the limits of our cosmic exploration, we encounter the boundaries of the observable universe, an astronomical wonder that stretches about 93 billion light-years in diameter. Here arises an exciting question. If the universe is only 13.8 billion years old, how can it contain such vastness? The key to this dissonance lies in the nature of cosmic expansion. The universe has been in a constant state of expansion since the Big Bang, stretching the fabric of space and widening the gap between celestial bodies. But what lies beyond the observable universe? This question remains one of the greatest puzzles of modern cosmology. Some regions of space are receding from us at a speed faster than light, forever relegating them beyond our visual field. As a result, the true size of the entire universe remains a mystery, potentially unlimited and unfathomable. As vast as the observable universe may be, it may represent only a mere fraction of the entire cosmic expansion, leaving us with the humble conclusion that there will always be regions of space, entire galaxies, and wonders that will never be witnessed, as they inexorably drift into the depths of a continuously expanding cosmos. In the infinite universe, every discovery takes us farther. Subscribe now for more amazing videos and join our community of cosmic explorers. Click the subscribe button and be part of this extraordinary journey. The cosmos is calling. Don't miss this opportunity to expand your mind and explore the unknown. Get ready for an epic journey beyond the limits of the known. Immerse yourself in the vastness of the cosmos as we explore from the edges of our galaxy to intergalactic horizons. Earth, our celestial home, a tiny blue dot floating in the vast cosmic ocean, is where all the people you know reside, every human who has ever lived, and all the stories. This is where our journey begins. As we venture away from our atmosphere and surpass the moon, leaving behind our familiar planet and the sun, we embark on a magnificent mission, the quest to understand the true scale of our universe. Leaving the comfort of Earth, our first stop on this cosmic journey is the moon, located about 384,000 kilometers away. Such an immense distance that, if it were possible to drive at 100 kilometers per hour, it would take over 160 days to get there. From the lunar perspective, Earth appears as a fragile sphere of blues and greens, enveloped in the vast blackness of space, a glimpse that puts us in a truly humble perspective. This is the view of Earth from the moon, a milestone in our odyssey. The next stop is the Sun, located approximately 1 astronomical unit away from Earth. This unit, equivalent to about 150 million kilometers, is the standard measure for distances in our solar system. Imagine that light traveling at an incredible 300,000 kilometers per second, taking about 8 minutes and 20 seconds to make the journey from the Sun to Earth. If we were to travel this distance in a commercial jet flying at 900 kilometers per hour, it would take about 19 years to get there. This is a powerful reminder of the immensity of space, even within our own solar system. The Sun, this fiery giant, provides the energy that sustains life on our planet from this extraordinary distance. As we venture beyond our native Earth and its solar companion, the Sun, we turn our gaze to Mars, our enigmatic red planet. Our neighbor Mars, when closest to Earth, is approximately 54.6 million kilometers away, but this distance can extend to 401 million kilometers when the two planets are on opposite sides of the Sun. To put it into perspective, traveling to Mars at the speed of a commercial jet would take decades. Over the past 50 years, the vast expanse of space between Earth and Mars has posed a significant challenge for space exploration. Rovers and probes sent to the red planet embark on a journey not only distant, but fraught with complexities due to the constantly moving distances and orbits. As we venture into the far reaches of our solar system, we encounter Neptune, the distant ice giant, located about 4.5 billion kilometers from Earth. Neptune marks the boundary reached by sunlight in our system, crossing the vacuum of space in approximately 4 hours and 15 minutes to reach the planet. This impressive distance underscores the magnitude of our solar system. Launched in 1977, the Voyager 1 spacecraft embodies humanity's insatiable curiosity and desire to explore beyond known limits. Over more than 4 decades, Voyager 1 has traveled an extraordinary distance of over 22 billion kilometers from Earth, becoming the farthest human-made object from our planet. In 1990, in response to a request from the renowned astronomer Carl Sagan, Voyager 1 turned its camera back towards Earth, resulting in the iconic image of the pale blue dot, captured at a distance of approximately 6 billion kilometers from Earth. In this image, our planet appears as a mere fragile speck in the vastness of space, poetically highlighting our responsibility to cherish and preserve the only home we know. At the edge of our solar system lies the Oort cloud, a vast theoretical sphere of icy objects. It is believed that this distant cloud extends over an impressive range of up to 100,000 astronomical units from the Sun, which corresponds to about 1.9 light-years away. The magnitude is so immense that it challenges space scientists to determine the boundaries of interstellar space, known as the heliopause, where the solar wind from the Sun is halted by the interstellar medium. It is at this point that the influence of our Sun ceases, and we enter the vast realm of interstellar space. The outer space begins to unfold before us, and the Oort cloud represents the final frontier of our solar system, where the influence of the Sun wanes and the cosmic journey to the galaxy truly unfolds. As we venture beyond the bounds of our solar system, our next point of interest is Alpha Centauri, the closest star to our Sun, located approximately 41.3 trillion kilometers away. This colossal distance is equivalent to more than 276,000 astronomical units, making the AU a less practical measure in this context. Therefore, astronomers resort to the light year, the distance light travels in 1 year, for interstellar measurements. Alpha Centauri is approximately 4.4 light-years away from us. Considering our current space travel technology, a journey to Alpha Centauri is virtually unimaginable. For example, the Voyager spacecraft, traveling at about 17 kilometers per second, would take over 70,000 years to reach this neighboring star system. This immense distance underscores the vastness of space that separates the stars and highlights the challenges of interstellar travel.